Okay, so let's wrap up our abstract function by doing 8, 9, and 10. And sorry I got some information up there, but this, again, there's a lot of things that still happen. I probably sound like a broken record, but this goes on quite a bit when we're talking about trig identities later on in our semester. And rather than just some, vague h, f, and g, right, we're going to have tangent, sine, and cosine. So lots of notation coming later. But here's how we would do this problem. We are told that h of x is equal to 7 and that f of x is equal to 3. And that we're also told that h of x is f of x over g of x. Right? Use this information to find the value of g of x. So we're going to begin by what we're told. Right? We know that h of x is f of x over g of x. And then we also know that h of x is 7, f of x is 3, and what we don't know is g of x. And we now have enough information to solve for it. Right here I could probably cross multiply. So we get 7 times g of x is equal to 3. To get g of x by itself, I'll divide both sides by 7. And so for the information that's given, g of x would have to be 3 over 7. So that's how we piece that together, based off of the information that we have. In the next one, we're told that p of x is equal to 5, and then we're further told that 2 times p of x times q of x is 1/3. So using what I know, right, here's the relationship that I have, and substituting what we know for p, I've got 2 times 5 times q of x, and that's equal to 1/3. And so we can now basically solve this equation for q of x. 2 times 5 is 10. Again, if you want to, we could cross multiply. So we end up with 30 q of x equals to 1. Divide both sides by 30, and we get that q of x is equal to 1 over 30. So based off of the relationship I had and what I knew about p of x, I could substitute that in there and find stuff. What's interesting about this is notice we're finding we have no idea about the input. The input's really not that big of a deal. But what we're doing is we're finding a function output given other function outputs in a relationship. So very, very famous idea that we're going to see a lot of in trig. Last but not least, we're told that f of x is equal to a half. G of x is less than 0, meaning that it's negative for all of its x's in the domain. Right? And we're also given that f of x squared plus g of x squared is equal to 1. So using all that information, how do we find the output value for g of x? Well, we begin by substituting stuff in. Right? We were told that f of x is equal to 1/2. So we have 1/2 squared plus g of x squared, I'm going to write it that way, equals 1. Well, this is 1/4 plus g of x squared equals 1. So to start solving for g of x, I will subtract 1/4 from both sides. All right, this is 4 over 4. So we get g squared of x is equal to, well, 4 over 4, take away 1 over 4 is 3 over 4. All right, now to further solve for g of x, I got to take a square root. But when we invoke a square root property like we did there, what we also introduce is a plus minus. All right, so that's a good old square root property. So right now my g of x is equal to plus or minus. When I break this fraction up, we have the square root of 3 upstairs and the square root of 4 is 2 downstairs. So we have two possible answers for g of x. Positive square root of 3 over 2 or negative square root of 3 over 2. And here's where I use this information. Right? We were told that g of x is less than 0, meaning that it's negative. So for us, the answer that we want is negative square root of 3 over 2. All right, so that wraps up our abstract function review. Again, a lot of these things, we're basing this idea in college algebra, but they have huge extensions into trigonometry. So please make sure you're understanding, you're learning. If you're not understanding, you need to ask questions, right? Jump on Canvas, ask those questions, make some hypothesis, ask for an office hour, whatever the case might be, because we really need this understanding to build on for trigonometry. All right, see you guys in the next round of videos.